In this video, we're going to talk about the classification of matter. Okay, so all of the ways that we break down how we organize and categorize matter. Okay, so the classification of matter. We are going to be making like a classification tree. So if you are writing this down for notes, I suggest that you have your page and you start in the middle. Okay, so you're going to start in the middle and we're going to branch out like this, and then we're going to branch out again. So just to help you organize, okay? And that's useless now. Perfect. Okay, so we start with all matter up top, okay? And matter can be classified in two main ways. Way number one is we have pure substances. And way number two is we have mixtures. Okay? Pretty easy, hopefully, right? So we have pure things and we have mixes. Okay? And the only way, well, the way to separate, so we're going to focus on our pure side first, okay? So if you have pure matter, there are two branches that fall within the pure matter category, okay? The first is going to be a pure element, okay? And an element is a specific type of atom, okay? This is not enough room. How am I going to do this? Okay, so because of the way that this page is oriented, we're landscape and not portrait, I'm going to have to focus on one side of the tree first and then the other side of the tree, okay? But I do want to just give you kind of the basic breakdown. So we're going to start with matter at the top, which can be organized as either pure matter or a mixture, okay? That's easy, okay? This is the easiest way to categorize matter. If something is pure matter or something is a mixture of different types of matter, okay? Then pure is going to break down into element or compound. Ugh, that's O-U-N-D. Wonderful handwriting, okay? You can see I don't even have enough space to breaking it down like this. Mixture is going to break up into homogeneous, and heterogeneous. So this is what our tree is going to look like. All right, on the first page, I'm going to focus on this side, and then we will focus on this side. All right, otherwise there's just not enough space on this page to break it all down. Okay, so keep in mind this is what your tree should look like. On we go. Okay, on the pure side, okay, we have elements and we have compounds. All right, so now we're all caught up, okay? So an element is just a specific type of atom, all right? So if you are literally looking at the periodic table, you have hydrogen, you have helium, lithium, beryllium, whatever, right? These are all specific different types of atoms. They're elements, right? Specific types. So when you're talking about this is like the purest matter you could have is a single type of element, okay? Like you have pure hydrogen, pure helium, okay? If I was going to draw a particle model, okay, of a pure element, doesn't matter what it is. Here we'll have pure aluminum, right? Doesn't matter. I just have this whole box filled up with the same type of matter, right? The same type of element fills up that whole container, all right? That's what a pure element would look like. There are a couple of weird elements. There's things called diatomic, Okay, di means two. Okay, so two elements, but it's still a diatomic element. So like the oxygen we breathe, right, that's O2. Okay, it's two oxygens bonded together. That's still one single type of element. Okay, that's one type of atom. So if I had a particle model of pure oxygen, like you could imagine an oxygen tank, what that would look like is two oxygens bonded together, but it's still just, this whole box would be filled up with just oxygens, right? Even though it's two bonded together, it's a diatomic element, it's still only oxygen in there, okay? So this would be a pure element side. Compounds are going to be two or more different types of elements bonded together. Abbreviating, okay? So I have two or more different types of elements that are bonding together. So easy examples would be like water, carbon dioxide. If you remember sugar from your biology days, C6H12O6 glucose, right? Okay, so I have two or more different types of elements bonding together. So I have, in this case, hydrogen and oxygen in one compound. Okay, carbon and oxygen in a compound. Carbon, hydrogen, and oxygen in one compound. Okay, so two different types of elements within the same thing. So if I was going to look at a box or a container of pure water, okay, I have oxygen, right? One oxygen and two hydrogens. That's a compound. That's one compound of water. And this whole box, this whole container, would be filled up with the same exact molecule, right? The same exact compound. So it's the same compound throughout. Yes, there's hydrogens and oxygens, but it's pure water. That's our pure side. Mixtures, right? Homogeneous or heterogeneous. All right. And we know these Latin roots, right? Homo means same. Hetero means different or other. Okay, so if you have a homogeneous mixture, it is the same throughout. It's mixed evenly throughout. It's mixed all the same throughout. Okay, mixed evenly or uniformly. So it's mixed all the way evenly throughout. It's a uniform mixture, okay? And the way I kind of like to think about a homogeneous mixture is that you can't slice it. I promise this will make sense when we compare it to heterogeneous, okay? You can't slice it because heterogeneous you can. It's weird. It'll make sense in a second. Okay, so a homogeneous mixture. If I was going to draw a particle model, it doesn't matter, right? So I should draw more than one for you, okay? But I could have a mixture of, you know, one type of atom, one type of element, and another type of element. And it's mixed evenly throughout, right? It's uniformly mixed. Those two types of elements are, you know, I don't know. I don't know if you need me repeating myself over and over, right? Those two guys are very evenly mixed. You could also have a heterogeneous mixture where you have, you know, a diatomic element and you have a compound, all right? So there you go. You could have a diatomic element and a compound, but they're evenly mixed. It's homogeneously mixed, right? It's not like all the pink guys are at the bottom and all the blue guys are at the top, okay? They're homogeneous, they're evenly mixed throughout. Good examples to think about this would be like your coffee or like a Pepsi or Coke, okay? No favorites, right? So imagine you open your Pepsi or Coke, or not soda because you're a healthy human being. The first sip that you take of that drink should have as much sugar and caffeine and carbonation as the last sip that you take. Okay, it should be mixed uniformly throughout. Same with your coffee, right? If you've mixed it up, the amount of sugar and coffee and whatever that you take in your first sip should be the exact same amount at your last sip. Okay, so that's homogeneous mixture. Heterogeneous is going to be the exact opposite, right? So it means that instead of it being mixed evenly, it's different, other, right? It is mixed unevenly. It is mixed differently. So this is not going to be uniform all the way throughout. Or it has distinct phases, which is how your book will describe it. The way I like to think about it is that you can slice it. Okay, and here's what I mean by that. So imagine you have a cake, okay? You have a birthday cake. Congratulations, happy birthday. Okay, you put frosting on your cake. You could take a knife and you can slice off just the frosting, and you could get just the frosting away from the cake. That is a heterogeneous mixture. It's not evenly mixed throughout, right? It's not like you have this, you didn't throw the frosting into a bowl and throw the cake into the bowl and then mix the frosting and the cake batter together, right? You bake the cake, that's in the middle, and then you put frosting around the outside. Heterogeneous, distinct phases. You can slice the frosting off of the top of it or off the side of it or something. That's not true here in a homogeneous mixture, right? I can't take a knife and like slice a side of it and only get the blue elements or only get the pink elements or whatever, right? That's how I like to think about homogeneous and heterogeneous if I was going to draw you a picture. If I had air, okay, just regular old air, and then I was filling up a helium balloon, but I accidentally left the helium from the tank on, the helium is going to rise to the top of the room, right? So I'm going to have some air still at the top of the room, but most of the helium is going to be up at the top. Here we have distinct phases, right? This is not evenly mixed, right? So helium in a room, iced drinks. So your iced coffee would be a heterogeneous mixture because obviously the ice is not going to be mixed evenly throughout. That's floating at the top. Salads. Okay. Hopefully not too difficult. Classification of matter. Good luck.